Hello, everyone. In this video lecture, we are going to look into how international data roaming works for 2G, 3G, 4G, and how different network elements are connected. So the, what is the call flow for inbound roamer? What is the call flow for an outbound roamer? And how international data roaming basically works. So, uh, upon the completion of this course, you'll be able to understand the roaming architecture, basically which network elements are specifically involved when you perform browsing using data roaming, how different roaming related configurations are performed. We're going to look into how the signaling roaming flow works, how the data roaming flow works, and then we can identify the differences between 2G, 3G, and 4G roaming. A little bit of introduction of few new network elements which are specifically involved in international roaming. The first one is your GRX, GRX peer. So GRX peering allow roaming between operators connected to different GRXs. Once a GRX interconnects with other GRXs, your GPRS operators are able to communicate with all other operators, and full global roaming across extensive length network is established. Basically, your GRX helps. It has an international communication links by which different operators are connected to one specific GRX. Wait, let me just add a pointer. So different operators are connected to one GRX, and a different operator may be connected to another GRX. And via GPRS peering, these GRX networks are connected, which allow the operator in A to communicate with the operator in G. And that's how international roaming works. Specifically, Elgapom is one service provider that is providing your TRX peering, and there are others as well. So we are going to have a little bit of deep insight how to this portion works and the specific functionality of your root DNS and your border gateway. Right. The other network element that is essentially used in your international roaming is your DNS. So a GPRS DNS now, this is a different DNS. One DNS is your GI DNS, which is basically used to resolve different URLs into IP addresses. This is your GN DNS, which is basically used for APN resolution. And in case of roaming, it tries to resolve the APN of a roamer into its specific GGS and IP address. So all GRX providers will offer DNS routing, and GRX providers provide the root DNS function during international roaming. So this root DNS is connected with your home DNS, your GPRS DNS, and that is how your resolution of APN works. The DNS between GPR networks takes the DNS of GRX as a route to realize the request and resolution of APN. So your APN is sent by your DNS GPRS to your GRX DNS, and by recursive resolution, this APN is resolved into the specific GGS and IP address. In this way, roaming can use the APN defined by homeland, and in the end, the net functionality, the next requirement is to get the GGSN or the PGW IP address of the homeland in order for a PDP session or a error to get activated. Now, looking into the roaming architecture, which is used in 2G, 3G. So this portion is basically your home network, and this you can consider to be the visitor network. So your home network has the SGSN, it has the GGSN, it has its own HLR. Then you have an SS7 signaling network. You have international gateway, which is connected by STP, and then you have international SS7 link. And via these links, you connect to the roaming international gateway via the SS7 signaling to the specific node. So The attached flow is quite simple and it's similar to your local attached flow. The only thing is that a UE is basically going to be connected via it is going to send an attached request to the visitor SDSN. The visitor SDSN will have its configurations, which is going to route it towards the visitor STP. The visitor STP is then going to send the request to the visitor gateway MSC, and the gateway MSCs of all the operators are connected with the international SS7 link. The international SS7 links are going to route it towards your home gateway MSC, from home gateway MSC to the home STP, and from home STP obviously to home HLR for authentication. So in case of local attach request, it is directly from UE to visitor GGSN. Visitor GGSN has a link available. The home SDSN has the links available to the home HLRs, so we don't have to go through all this extensive uh, communication. But since this SDSN belongs to a different operator in a different country and HLR is a different country operator, so we have to get the connectivity via international system. So once your attached request reaches the home HLR, authentication is done like routine authentication in normal flow. User is attached if authentication is successful. And in SDSN, we define E to and foo conversion rule to ensure the user request reaches home network. We're going to look into the configuration in the next slide of how this communication works. Now, national international SS7 signaling networks are independent, and the formatting of the signaling point code also differs. Therefore, networks from different carrier must be connected using STPs, and international gateway must be deployed to connect the national to international signaling, because this is going to be using some signaling codes which may be used by the other operator signaling code as well. So you need to have a unique code that is going to identify the user belongs to which specific operator. Hence, we need to connect these national networks via some international SS7 signaling network. Okay, so when we poke into the configurations for 2G, 3G, these configurations are done on the SDSN, and from a Huawei Note perspective, the first command that you need to add the configure is add IMSI-GT, where you specify the prefix of an IMSI, and then you specify the GT, and then you can to have an optional code to mentioning that this IMSI conversion rule is for which specific country. So what this GT conversion rule does is that it takes your MNC and MCC, which is a 5-digit code, and it replaces it with a CC and NDC, which is also a 5-digit code of that country. Because your CC and NDC, which is your global title, this is universally recognized. For example, there is an operator whose mobile numbers start from +93,201. Okay, but its IMSI may start with like 32303. So 32303 may be a GT of some international country of a specific countries. So if in your attached request, if you bring your complete IMSI, that is going to be routed towards some other operator. So in order to ensure that your routing and your reverse routing is done successfully, your MNC and MCC need to be replaced by the CC and NDC, because the CC and NDC is something which uniquely represents one specific operator of a country code. So it consists of a country code and then national destination code. Then yeah, that network destination code. So the IMSI conversion rule is essential to ensure that your request, once it reaches the international basis level links and reaches to its home HLR, so your international SS7 network and your STP know towards which correct operator it needs to route your request. And that routing is done based on your GT. It is not done based on your MNC and MCC. So this configuration is essential. Okay, this second configuration which you need to configure is your add connect element, and this command basically allows you to perform testing on some specific IMGs. So you have an option of adding a match IMG. So if your complete IMG was 123051108021003, so for testing purpose, you're not going to allow roaming for each and every user of that specific operator. So you're going to open roaming for one specific IMG or multiple specific IMG. So this add connect element command has the option of specifying a specific IMG which can be allowed for roaming for testing purposes. Okay. Then once your testing is done and your roaming agreement is signed, so you can replace this patch IMG with basically this command, which allows all of the IMGs which are starting with this MCC and this MNC uh, to perform international roaming. So any user belonging to this country XYZ, if that user comes to your network and you have these two commands configured, so his 2G, 3G roaming is going to be allowed, and his attached request is going to be successfully processed by the SDSN, and it is going to send that attached request to the STP to be tested into his home HLR for authentication. Right. Uh, the other thing, the other configuration which we need to do is on border gateway. So if we look back into the introduction of GRX peering, so all the operators which belong to which are connected with GRX, this connectivity is done via border gateway. Border gateway, as the name suggests, it is a gateway of your border of the operator. So in order to have any communication outside your network, all communication must go through this border gateway. So in order to allow an operator G, a user of operator G, to be able to perform international roaming in operator A, we need to allow the configurations of operator G on this border gateway as well. Okay. So on border gateway, basically what we add is the ASN number. Okay. So if you look into the IR21, which is provided by the roaming partner, so it has your GP information as well, and it has the ASN information as well. A reference command is basically this. When you log into the border gateway, so it's a simple command. You're going to mention the ASN number here, and this command is going to be a static command, and here you are permitting this ASN number traffic to be allowed to pass through this border gateway, right? And when we look into the 4G roaming uh, architectures, so in this you have your visitor MME, you have your visitor SDSN, and you have your visitor maybe PCRF. This is an optional uh, an optional flow. Usually we are using home PCRF and home OCS. And your MME is basically connected to an edge agent. The edge agent is basically connected to your GRX and IPX provider, which is then connected to your home edge agent, and the home edge agent is connected with your HSS. So your request of attach is going to be like this, that the UE is going to send an attach request to your visitor MME here. The visitor MME is going to send a request to the visitor DEA, diameter and agent, okay? And the DEA basically has the links towards your international links. So it is going to connect to your international the links to GRX and IPX provider. And that is then going to route your request to your home DEA. And from home DEA, you have routing available, which is going to go towards your HSS. Right? So once your request reaches the HSS, authentication from HSS is done like routine authentication. The user is attached, if authentication is successful, I would abandon MME, Uh, Again, a conversion rule needs to be defined in order to ensure that your MNC and MCC is replaced by a TT. So this edge agent is a diameter routing agent, which is also called a DRA, which is deployed at the network edge and function as a DEA. On an IPX network, the DM is deployed to support routing addressing for diameter signaling between the visited, and the home in the network, right? The configurations related to 4G roaming. So the first configuration is add in the characteristics, and here you specify the MNC and the MCC in MZ3. And then you specify the local index as well. The MZ3 is going to be your MNC and MCC. The local index is basically the diameter AD, the diameter ID of a local MME. The second command is basically to add a diameter route. So you need to add a diameter route towards that specific RP MME. And you need to mention a tier ID as well, which is going to be the diameter ID of your local DEA. Okay. So this local DEA, it it is defined in your diameter agents, which we'll look into earlier, of how the configuration of S6A and S6T is done. So you specify in the realm name, you specify the operator MNC and MCC. You specify towards which diameter ID you need to send the request. Then you have the option of adding a description to identify that which country this diameter route is defined. The third command is basically combining these two. So you're basically you're basically adding the IMSI prefix toward this specific DEA, and that specific DEA is then going to send the request to the TRX and IPX. So the add IMSI HSS command is basically combining your IMSI prefix with your HSS realm, and HSS realm is going to be this same realm name which is mentioned in the add DM route command, and you have the option of adding the country name here as well, right? So these three commands are essential to be configured in uh, at IMEME side, and the border gateway configuration is the same. So if you have the ASN number defined for 2G, 3G, there is no need to define the ASN number for on the border gateway again. Right. So once your attach is successful, you have been successfully authenticated by your respective HLR and HSS. The next is basically to create a PDP session in 2G, 3G and to create a bearer in 4G. So the different network elements which are basically involved in this is basically on the visitor network. You have your BTS, your BSC, you have your Node B and RNC, you have your SDS, and you have the DNS, which is basically then connected with with the GRX provider, which is then connected with the DNS and the GGSM as well. Okay. So your U is going to send a create PDP request to your visitor SDSN. The visitor SDSN is going to see that okay, this APN I don't have locally defined. So it is going to send that request to the visitor DNS. The visitor DNS has the configurations available to resolve the local APNs. And uh, and for all those APNs whose configuration is not available in DNS, there is a common route available to route all such requests towards the root DNS. So once you visit a DNS, identify that this isn't a local APN and this is not defined in my configuration. So it is going to route it towards the root DNS, and this routing is done via your visitor BG. So your visitor B, via visitor BG, your request is going to be sent towards your root DNS. Now, root DNS has the information of all the operator DNSs available and all the operator APN information available. So if you are going to create a new APN which may be used for roaming, so you need to indicate it towards your GRX provider to update it in its database that okay, this APN will be resolved into which specific DNS. So your root DNS is basically going to provide back the IP address of your home DNS. So your APN is going to be resolved here, and here the root DNS is going to recognize that okay, this APN ABC is being served by operator A, and operator A's home DNS IP address I have available. Okay, so this is then going to be returned back to your visitor DNS. Okay, and the visitor DNS is then going to send a request to your home DNS to resolve that APN, and the home DNS, like the visitor DNS, has the APN and its corresponding CGS and IPs available. If we look into this flow, it is going to be easier to understand. So once your SGSN gets that APN and it recognizes that I do not have that APN locally, so it is going to send an APN FQDN to your visitor DNS. The visitor DNS is going to send it to your root DNS. The root DNS is going to return back the home DNS IP address. It is not going to return back the home GGSN IP because it only has the DNS IP information available. So this home DNS IP is going to be returned back to your visitor DNS, and the visitor DNS is going to send the same APN FQDN to the home DNS. Now, home DNS has the information that okay, APN A is going to resolve into IP1, APN 2 is going to resolve to IP2, and so on and so forth. So home DNS is now going to return with the home GGSN IP address. This home GGSN IP address will be returned by the DNS to the SDSN, and then SDSN is going to send in a formal create PDB context request with that APN to the home GGSN. And home GGSN will then communicate with OCS, communicate with PCRF, and if all its requirements are complete, uh, the from that specific APN IP pool, one specific IP is going to be assigned to that specific user. And then SGSN is going to send the activate PDP response to this specific user, and then IP address is assigned to the user, right? And for 4G roaming, in 4G roaming, the different network elements that are involved are your visitor network enode B, visitor MME, visitor SDW, and visitor DNS. And obviously, this is connected via border gateway. And via border gateway, it is going to connect with the GRX and IPs provider. Via that, it is going to connect to home DNS and the home PGW. The flow is going to be more clearer here. The MME is initially going to identify which SGW is being served, so that is going to be done based on TAI. So based on tracking area ID, it gets the SGWC IP address, and then it is going to send the APN FQDN. So the APN FQDN, the same procedure is going to be followed, that the root DNS is going to give the home DNS IP address, and the home DNS is going to give your home BGW IP address. Okay. So once your home PGW IP address is provided to the DNS, DNS is going to return it back to the MME, and MME is going to return back to the UE. So once UE has that, UE is going to send a create session request on the MME, which is going to be sent to the SGW. The visitor SGW is going to send that same to the home PGW. And the home PGW is going to return back the create session response with the specific information like handling ID, the QCI, and the IP address. So for 2G, 3G, 4G, the flow is a little bit similar. The only thing that is different is the name of the nodes. And then there is one SGW node which needs to be resolved based on tracking area ID. Uh, and we compare the different architectures. So in architecture, obviously, uh, the RAN architecture is different, but the main thing which is differentiates is this, that in 4G you have the DEA available, and in case of 2G, 3G, you have your STP, and your STP isn't connected with your gateway MSC. So both of these nodes are now replaced by the DEA or the DRA, which is directly connected to your NIPX. Right. So this is the signaling flow, right? So once the IP address is assigned to a user, the user request is going to be sent from the SGW from user to the SGW over S1U interface, and SGW is then directly going to communicate via border gateway towards the PGW of the home network, right? And the home network PGW and the GGSN is going to then communicate with this specific ISPs. So a roamer UE is going to we're going to send request to BSC to the visitor SGSN, or in case of port is going to be visitor SGW. And via border gateway, this request are going to go through the GRX, from GRX to the border gateway of your home network, from border gateway home network going to go to your GGSN, and then GGSN is going to send the request to the specific ISP or the specific web server. Its response is going to follow the same path via border gateway, via international links towards your visitor border gateway, SGSN, BSC, or SGW, E node B, and towards the specific users. So it's going to be visitor SGSN, visitor EG, GRX, home GGSN, and home ISP. Right. So I think this concludes the roaming configuration, the network architecture, and the basic flows. In the next video, I'm going to introduce how to troubleshoot any roaming related complaints. And there we are going to see a little bit more depth into how your inbound roaming complaints are going to be handled and your outbound roaming complaints need to be handled. Uh, a little bit of introduction of what is the difference between inbound roaming and outbound roaming. So an inbound roaming means that this is your network and you have a roaming agreement with operator B maybe. So if an operator B user comes to your network, he comes to your country and he is using services from your network, that is called inbound roaming. And if a user from your network goes to operator B and he wants to use data services over there, so that is basically called outbound roaming. So in a inbound roaming, uh, your network MME is going to be used, your network DEA is going to be used, your network DNS is going to be used, and your network SGW is going to be used. Then and in case of outbound roaming, your HSS is going to be used, your PGW is going to be used, your DNS is going to be used, and obviously your border gateway is going to be used. So this is the basic difference between your inbound roaming and your uh, outbound roaming. So I hope you would have understood and got a basic insight into how international data roaming works and what are the basic network elements and what is the basic architecture and the basic call flow. See you in the next video. Thank you very much and take care. Have a nice day.